much for coming along tonight, be it in person or online. My name is Romana and I am a networking and community engagement coordinator for WOMEESA. And we've got our colleague Fernanda here as well, who will introduce herself in a minute. And thank you so much for coming along to our National Science Week event, helping to bring out that STEM engagement, especially in our earth and environmental sciences. Fernanda will tell a little bit more about WOMEESA in a minute. I'd also acknowledge our First Nations people and our first scientists here in Australia. So tonight we are on managing the lands of the Turrbal and Yagara peoples, and we'd like to acknowledge their elders and respect past and present, and extend that respect to our emerging and future scientists of the future. And we also do have a side note from the evacuation and emergency point of view, making sure that we know where we are when the beeps and the whoops happen in the building. And we are on the 24th floor tonight, so it will be quite a nice hike down the stairs. That's where we can swap that one. We're already in that one. As a alert from me, handing over to Fernanda.
Thanks everyone for joining us. Fernanda, I'm Vice President of WOMEESA. And for those who don't know much about WOMEESA, we are an inclusive community that supports, amplifies, and advocates for women and marginalized. And our mission is to ensure that everyone has equal opportunities in earth and environmental sciences, and to build a stronger, more deep, diverse, and scientific community for the future. And tonight's discussion is part of National Science Week, and it brings together voices from across the geoscience community to explore how we can connect with students and inspire the next generation of scientists. And we are delighted to have Tony Shellshear, who is our moderator this evening. Tony is a geologist with over 40 years of experience across exploration, mining, and technical data management. He is a member of AUSIMM and serves on the Queensland Committee of the Geological Society of Australia, where he has led the DSA Rocks and Mineral Sets project since 2016, delivering over 1,500 sets to schools and institutions in Australia and beyond. In 2018, Tony contributed to the QCAA's curriculum revision for Earth and Environmental Sciences, assisting with content reviews, sample materials, and exams. And joining Tony on the panel, we have Joanne Wilkinson, Karen Aurisch, and Keegan joining us online. And before we start, here is the panel structure. So after the panelists introduce themselves, we will have for about 30 minutes questions that were submitted during the registration, and then we will open the questions to the audience. And after that, for those in Brisbane, we have a networking session just around the corner. Thanks, everyone.
I'm Joanne Wilkinson. I work at the Queensland Museum in the fossil preparation laboratory. So I'm a fossil preparator, and I work in a team, the Geoscientist team, that is made up of 2 curators who do most of the research. There is a collections team, 2 people who do that, and I'm on the technical side of things. And I have probably usually about 6 to 7 volunteers that help me out in my lab. I've been there a long time, about 34 years, and seen lots of different progress through dinosaurs coming out of the ground, new regional museums being found, up and coming, fabulous regional museums that weren't there 30 years ago. So it's been a really lovely time. So that's me. I started out a long time ago. A lawyer. I did a dual degree. Science law. And as it turned out, as I progressed through that, I loved science part, and I liked the law less and less as time went on. And it was just absolutely by chance I started science. I was driven by anime for whatever reason. Packaged that up with the science subjects, because that's a sensible thing to do. And so I did the foundational one, and then I sort of just followed what I enjoyed, and then at the end of that, I audit law, and I took a graduate role with time doing petroleum exploration. Moved through from Woodside to the Aurisch. I'm wearing 2 hats because I'm also and the education share of the concepts, XCG, which is the Australian Society of Exploration Geologists.
Sharon, and last but not least, I've got Keegan McGuffie over my right shoulder. Keegan and I go back a while. Keegan particularly from the industry also together. Some of the right middle sets or still kits that we've been sending out now for just a year though. As you see,
Thanks for that, Tony. And they are sure are fond memories of coming over and putting those rock kits together, learning to use the diamond drill saw. So I guess a little bit about me. My background, I studied a Bachelor of Science at UQ, and that was in both geology and geography, specializing in GIS, so Geographical Information Systems. And then from there, I took a job as a geologist, specializing in contaminated land and groundwater. So I got to travel around Queensland and learn a little bit more about what we have in terms, I guess, in terms of the broader geoscience. At university, we focus so much in specific pigeonholes, whereas the environmental geology sector is very broad and vast, and it's not something well known. So I enjoyed that work, but found that not a lot of people had the same passions nor respected geoscience as much. And there was a lot of misinformation and disinformation out there. So I've turned to teaching. I'm in my final semester of my Master of Teaching for secondary, specializing in Earth and Environmental Science and Geography. So I'm hoping to sort of get the right information out there and change perspectives, even just one cohort at a time, one small area at a time, because it's really important information going forwards into the future that generations can spread and change our perspectives and views on geoscience. So that's why I'm here, and I'm glad to see so many other people are joining in that fight. Thanks, Tony.
quite a lot of questions have been submitted, some by attendees before this. Questions here and there, because there are also some questions quite specifically. For the whole panel, the first one relates to field trips, practical activities in the education system in Queensland. The question is, what are some of the local field activities? Who wants to have a shot at that one?
I can start with mine because then, yeah, okay. Is that too? So field trips that I came up with are, first of all, Kangaroo Point. And I thought about the accessibility of these. So Kangaroo Point is a really, now I'm sitting with two geologists and I am not a geologist. So I'm just going to say, as I can add to it, there was a massive Aurisch 230 million years ago in the Triassic. Pyroclastic flow filled an ancient riverbed. And the rock type is known as the Brisbane tuff. So those cliffs along Kangaroo Point are the Brisbane tuff. Now, over time, tuff probably just eroded a little bit from the river, but the harder tuffs are left there. They also, I mean, if a student group was to go down and walk along the cliffs in a excursion, the teacher could also talk about how that material was quarried, and there in the early settlement of Brisbane, that material was used to build buildings as well. So it sort of brings both of those ones in. The other ones that I just thought about myself was the Sanford Valley, going up to Jolly's Lookout along the rim and looking out over the valley and explaining that that was an example of a luton that never actually was expelled out of the earth. It was down and it cooled under the ground. So granodiorite that has eroded, and there's a contact metamorphism that happened around the edge of that luton, and that is the resistive walls of the valley. That's what we could see. So the granodiorite is eroded, and that's what you see. But it's a beautiful visual of that exam, and there's a lovely. I think there's an explanation of this one. They might do. I'm a little bit ashamed to say that I have done many field trips to South East Queensland. So I phoned a friend, and that friend pointed me directly back to you, Sonia. And he said that, I mean, the resources date back. They're still good on the GSA website in terms of the field guides. And I actually spent today, well, the website says out of print, not available. And then I walked in and saw a whole bunch on my table and I was like, I might one of those. He also said, so my family friend is an old colleague at Origin. He plans a lot of trips for staff. And he said, before Moreton Bay, Cliff, or a couple of horror. And the other day I was out with a dear friend of ours from Davey in Stradbroke Island, picking up rubbish from the beach, and a bunch of school kids came by, and we had a brief chat, and we were on a field trip. So even Stradbroke Island, which is a close stuff. And what we need really is the field guide to support the exercise.
Keegan, did you want to add something to that?
I think there have already been some good suggestions in there, especially if you are metro-based, then the Brisbane Tuff and around Kangaroo Point Cliffs is a good one. And as Joanne mentioned, a lot of our buildings also have different geologies embedded in them from old quarries. If there's time allowing and accessibility requirements allowing, there's also Mount Cootha that you can go up to and have a look at some of those granites up there. It's very easy to see contact metamorphism on Mount Cootha, and it's nice and close for any metro schools. If you are a little bit further south towards the Gold Coast, places like Springbrook National Park, again, pending accessibility and location, they can be good ways to connect the Wollumban National Park volcano and that history there through to our Brisbane Tuff and other volcanic events. If you're further up the Sunshine Coast, then the Glasshouse Mountains are going to be a really interesting way of looking at columnar basalts, as well as some of the different erosion that occurs. And you can sort of pick and choose how many you would like to go to. That provides students an understanding of the different vegetation that can grow on different rock types as well as you pass through, and understanding soils. And for those of you who may be familiar with the University of Queensland field trips, both the structural and sedimentology field trips actually go down to Shorncliffe, which is quite an accessible area just to have a look at the rock face, if you go at low tide, that is. So you can have a look at folds, faulting, but also sedimentary layers that can help with understanding uniformitarianism and all the different laws that go along with that, so students can visualize it. And if you head across the bridge, Redcliffe has some of laterite profiles and other rocks that can be quite interesting. I've popped the link in for the field guides for GSA. I'm also just going to find a link for TSEP, which is another teacher's education for earth science, and they're running a few Queensland field trips as well that might be worth checking out. You can book them specifically with your school so that if you need guidance around field guides, that could be an option as well. I would like to say that I'm quite impressed in terms of how earth sciences, when they have the availability to be implemented in a school, are taught. It's quite comprehensive and multidisciplinary, which I believe is important in the earth science discipline. Whereas I think when you go to university, there's quite a lot of segregation between units. You might do a sedimentology unit and you might do a structural geology unit. There are some instances, if you do get the chance to do field work, where there is a combination of those skills. But once you go into university, it's not a requirement to ensure that you cover all of those disciplines. And you can sometimes find yourself being pigeonholed or feeling that you have to go into a certain aspect of geology. So when we are teaching students at a school, reminding them to stay open-minded and connect with other people from different disciplines, take electives at university. And I'm just going to throw it in there because I'm geography as well. But geography is earth science, and no matter how much the humanities and science departments are split at schools, there's quite a lot of overlap. So it's always worthwhile chatting, especially if you're teaching something like Year 8, chatting to the Year 8 geography teachers, because they're learning about weathering and landscapes and landforms at the same time that you are learning about geology and the different, great, I'm seeing some chat support of geography. So they're quite linked, and students might not realize that. And if they're worried about an ATAR for a science degree, geography is always an option as well that they can go into and explore from there. So I think that it reflects in the industry, similar to university, you can become pigeonholed. And what I loved about environmental geoscience was that it was still multidisciplinary. So if we can keep reminding people and bringing that new view of multidisciplinary geoscience from schools through, that would change a lot of perspectives. So I'd like to see that happen in the future.
Oh, question of Joanne there. The syllabus covered mass extinction events.
Yes.
Mate, this perhaps mate feel relevant to students. What fossil evidence to Australia tells the story?
Yes. So I guess the relevance of any extinction is that we're warming up pretty at the moment. So we've got ice caps melting and we've got all sorts of things. So it's hard what to think of an extinction event not being relevant at the moment worldwide. But in Australia and around here, in the Panamanian, we had all over the world, there was lots of extinctions. The main one that we are close to is, and that we see is in Ipswich, in the plants that are reserved in Ipswich. Before the Panamanian extinction, we had a lot of Glossopteris, and then they just disappeared. So after that, we've got Dipredium. So you can go to Ipswich to, and it's probably in one of the books, to the Denmark Conservation Park and take a group of students. There's a fabulous display there that is protected, and you can take the children on a walk around the park. It's very well signposted and it's a really lovely place to be. There is a chance also, I think, that you could find something, but I don't encourage anybody to take a whole group and start digging. But, you know, things that are falling out, you can pick up off the ground and probably see a leaf or two in there. But have a little look on the website, and I'm sure it's mentioned in one of the books. So it's a great place to go. Oh, right. That you can click. So that would be a fabulous, you know, talking about how the vegetation just changed was one thing at one point, and the reason why, again, I'm standing aside for geologists, but the reason why that the global temperatures warmed up was a massive amount of lava flowing over a very long period of time in Russia. And that just was enough to increase the temperatures and change the plants. Once the plants change, then everything really changes and the temperature changes. So in Australia, it meant that for vegetation change, the animals change, everything really changes. So I suppose which is the place to go. That one.
Actually, if you like ophthalmology, there's a tremendous amount of carbon dioxide source of chemical yes, concrete and light. For each of golf has been one of the biggest challenges I think in communicating the risks and potentials of these market events.
Yeah, transition. That we're going through now. Where, you know,
No.
think about the scale of the hot block, you know, on its own, it's enormous. But break it up into the challenges that they're going to have to meet along the way, and make them sort of feel like they're part of the solution. I think that sort of helps. And to explain that, you know, if the transition's this long, we've started, you know, we've found clever ways to deal with carbon in terms of capture and sequestration. We're looking at alternate energy sources in terms of wind and solar and hydrogen and like potentially in some places nuclear. We're looking at like no carbon and low carbon products again through the sequestration. And so, you know, great lot of work done in like solving some of the challenges. And then there's the next lot of challenges where, you know, the solutions are currently being worked and, you know, we're close to progress. And then there'll be the ones in the future. You know, like how do we make cement without a huge carbon footprint? You know, and it's relevant because it's
Used. Yeah.
exactly. And it's thinking about all those things, which, you know, the mind boggles. But I think putting the context around it, that it is a transition. I wish I'd saved it when I saw it, and I didn't, and I can't find it again. But I saw this amazing diagram once, and it had all the transitions in history. Like when we went from humans with no wheels to we discovered the wheel and then like fully implementing life with a wheel. It wasn't just a wheel, it was a whole number of things. And any transition in itself it's decades, right? You can't transition like that.
It can be very wrong.
Yeah, decades up to a century, right? And so we're on one now with the energy piece. And I know everyone wants it to happen right now, but it won't because of the way we deal with lifestyles and our expectations around how society operates. And so I think just sharing that with the kids to say, like, we're on a path and, you know, and we will get there and everyone needs to be a part of the solution.
That's the secret of take interest. Be part of learning what some of these potential hazards are, earthquakes, volcanology, sea levels. Good me. Keegan, did you want to throw anything in there?
I think it's really important to outline the discussions when you're having them with students to say that similar to history, when we're looking at things that have happened in the past, we're looking at them to learn from them. And when we're looking at things in the future, they are scenarios and we have a say on those scenarios. So we have to balance and know our students really well as to making sure that it doesn't feel as though the responsibility is put on an individual student. So they go home feeling like they have to do this, this, and this. Otherwise, we're going to burn up in next few years, or that they can't do anything at all and it's all a climate crisis and big companies are just going to bring us down. So it comes down to balancing those two and whether we embed positive. And I think it was a little hard to hear, but I think you were saying looking at how change has consistently happened and how we are better embedding sustainable practices, putting them throughout the lesson to make sure that we're balancing the positives and always ending a lesson with a positive. It's interesting to try and link in with other subjects as well if they are looking at a particular case study, again in geography or even in English if they're looking at a humanitarian crisis in relation to a book. You can connect that and say, there's lots of things happening and we always work through them. We need to pull together and here are some ways that we have done that. And here are some ways and technologies that you can be a part of moving forwards. Does that make sense to everybody?
I think that's very valuable of communication, collaboration.
Yeah.
Trying to get people to work as a team rather than just saying, it never does be good to run in little decreasing circles. And some earth science and environmental hazards we can't do a lot about. Then we've got the political hazards we can't do.
Yeah, that's true.
There are a lot of things we can do something about. The first thing to do is talk about, communicate those things. So we might take a quick break there from the questions we've got here and field a couple of questions from you guys.
I think that sciences, I can see schools. Only as an option in a few schools, not across the board. My view is, you know, we need to be targeting private schools from all the way through and get them interested. But what's the biggest barrier with the general non-acceptance of earth sciences in most state schools, like chemistry's, like accepted, other sciences, biology.
My two bobs worth in there, being an economic geologist, I work a lot at mineral resources, and we need them, but we need to be responsible. But I think recently there's been such a point back against economic geology and mining is destroying the planet. Everyone's have used their iPhones, drive cars, and all the rest of it. But what we need is responsible mining. That has had a huge impetus. There's quite a lot of universities and schools who have removed earth science from their curriculum just because they didn't want the flag. So one of the most encouraging things I saw when I was first invited to part of the QCAA review of the changes to the earth and environmental science curriculum for years 11 and 12, I was told what I would do was combine earth science and environmental science. Yeah, right. So this is going to be quite a rid of the earth science. And when I came along and sat down with Ross Wilson, who was working at QCAA at that time, I have to say I was nothing but impressed. They have done that so incredibly well in combining them because they do work very closely together. They're critically important and they've put a tremendous amount of work into it. And I must admit, I was blown away with the job that they did in combining earth and environmental science. And I strongly encourage that combination then be encouraged throughout the schools here. My vote.
I was just going to say, because we've talked about this a lot to the education committee at ASCG, and it's a tricky chicken egg scenario because universities around Australia closing down geology, those courses this year. So then it's a really tough ask to then say to teachers, children, even me as a parent, hey, like come along and do this thing and then get them really interested in it and then land them at university and there is no option to pursue that interest. So sort of the answer to the university problem, maybe I should say challenge, is to sort of bring the awareness of options, benefits and the excitement, everything around earth science. But I think as well, there has to be, because there is a lot of instability in the mining space, mineral space, because the resources, fluctuate, demand, and that's nervous for people who are looking into what's my future going to be. Same with petroleum. Maybe less fluctuation, maybe just like a gradual decline. However, there's so many applications outside of the resource piece, and even within the resource piece, there's such a huge requirement for people to still contribute to, like I was talking about, the transition and the challenges associated with that. So I think it's about trying to give people some confidence that, there are, really valuable, really important roles out there at the end of the line. Universities, they'll only open those courses if they have numbers. It's just fact. How do you get those numbers? You've got to go back in that direction. The schools. And so ASCG renewed their support for TCEP, which I think Keegan mentioned already. So we're working a little bit with Jill Stevens, who's incredible. And I don't know if you're all completely across TCEP, Teaching Earth Science Educators program. But that's an incredible resource. So she offers professional development in schools, field trips. I don't know if this is controversial. I'm not sure if she's competitive, mineral and
Not at all.
you name it. They are doing an awful lot. It's all available. I think someone said they're going to put the link up in case you're not aware. But that's where it starts, right? So ASCG's solution at this point is pouring as much funding as we can into the groups who are on the ground providing support to educators. TCEP's one of them. I don't know if they're lines outside of the state. There's AusEarth in WA and Cord Learning, and there's a bunch across Australia. But TCEP's the one with part of Queensland. Taking a look, you're reaching out to Jill, who's amazing, and I can help you as well. My ACG hat on. Well, as far as the museum goes, I had a chat to one of our programmers yesterday, and she said to me, the museum is a safe place to talk about dangerous situations. So, of course, many, many people come to a museum to find information about all sorts of things. So we do age-appropriate stuff. We try not to scare everybody, but, the facts are there. We've got scientists doing forest studies. We've got people doing coral bleaching studies up in Townsville. So the evidence is all around us, and, we do present it in the appropriate way and not try to scare people. So that's what we do.
Did you want to add anything to that?
I think there's that high level discussion that we're already having around potential barriers. When it comes to an actual school level barrier, senior students aren't necessarily picking earth and environmental sciences because it scales bad for ATAR. And when I've spoken to a lot of students, that is something that is coming up. Additionally, there's a lack of teachers who are confident in teaching earth and environmental science. So if there's only 5 or 6 students who are wanting to do it, the school may or may not go ahead with that. They would have to do it through distance education. When I was at high school, I had that situation. I had to do some subjects through distance education, and it's not for everybody. It is quite hard. So we lose students through the cracks who may be interested, but just don't have the numbers in the school. One, because they don't have teachers who are confident teaching it in junior and who are wanting and trying to promote it for senior. And two, because they could be taking something like chemistry or physics, although chemistry is coming down in scaling, that will bump them up a little bit. A lot of universities just recommend a science. And if they're going to university, they're going to want one that scales well. For students who are not looking for an ATAR, I find that there's actually much more of a mix when you look at the statistics from QCAA, the schools that are offering these subjects and the numbers. There's more people who aren't looking at a university course, and we're missing out on capturing those students who may be looking for more of a TAFE-based or hands-on approach to learning, because university and ATARs are just a little bit scary for them. And that's completely understandable. We have a missing link where we could be capturing students and helping them apply their love for the outdoors and earth science, but not in a super academic way. I just wanted to also touch on something from the chat while I'm here. That Kayleen said that potentially it could be that place-based, it's a very place-based science like geography, and that might throw people off. On the other hand, I think in regional, rural and remote locations, this can be a draw card, and it's also really critical to be linking in First Nations knowledge of land. Having that place-based grounding can engage students on country much more than other subjects, and we're engaging through field trips and going out and understanding the lay of the land. There's so much knowledge in First Nations groups of their local geomorphology and geology that links to stories that a lot of the time aren't heard in geoscience. So I think it would be beneficial to maybe explore that in a teaching scenario and in a university scenario more than we do at the moment. It shouldn't be a scary thing to be place-based, I hope at least.
Thanks, Joanne. And Keegan, just while they're there, there's another question here for you on geological timescales. I don't know if you read that one. A little bit of a curly one. But I think in Australia, we're very well placed to better understand geological timescales than many other countries are, because of the huge range that we have from the very oldest of rocks on the planet to most recent. What's your exposure in that area, and how do you approach trying to communicate wrapping 4.5 billion a year?
That's a very good question. And again, I think it really depends on the age of the students you have. So if you're working with junior students, say in year 8, when they're first engaging with geological time, there's some good programs online, such as Earth Viewer, where you can watch everything change on the geological scale and they get a sense of time, but also getting them into a kinesthetic activity where you might take them out to the oval and you can draw a line and say, right, this might be where we are today. I want somebody to run down to the other end or to the goals, wherever it might be, and approximate, if we stand someone here between the two, this would be where humans came into existence. This would be where we had flowering plants, and you just space it out for them. So when you send someone all the way down to the back of the oval, they can get that understanding and they will relate to it and they can share that knowledge as well. They'll probably pass it on. It's something fun to do. So they can engage with it in a visual sense from an Earth view. I'll pop a link in of the time changing for the continents, but then physically themselves. So we can talk about deep time as much as we like. When you're getting to senior students, they've already looked at things like the universe a couple of times. Their understanding of time is a bit better. And going back and looking at specific fossils of the evolution of a stromatolite and how that's progressed, particularly in South Australia. We have a lot of resources we can access around our own geology. So there's I think it's the Brakina Gorge Trail that there's good resources for, and that walks us through a lot of geological time periods within Australia. But again, gauging it where your students are at and seeing if you can make a visual or physical link to it.
Yeah.
Hope that helps.
That's a great suggestion. That's an excellent suggestion. It gives them a sense of space and proportion. I've got another question here for Karen on feasibility studies for resource extraction. What factors make or break potential mining projects, and how can we help students understand the significance of this and some of the factors that go into determining whether a mining project should or could go ahead.
Yeah. So okay, so I think broadly you can break the feasibility of, I'll call it resource operations, into maybe 4 buckets. So personally, I think the most important bucket is the quality of the resource, if you like. So the geological characteristics that you're working with. So in the mineral space, that's the size of the deposit and the grade, and in the petroleum space. Again, it's whether you're looking at what phase of the hydrocarbons you're in. So geological characteristics. Then you've got the economic viability, equally important, but slightly less exciting. Then you've got the operational efficiency, so how you're going to get it out of the ground. And then finally, but equally importantly, I think they're all in the mix, is the social and environment sort of consideration. So yeah, I think a successful mine needs, obviously a sufficient quantity and quality of resource, efficient extraction methods, favourable economic conditions in terms of commodity prices and all those kind of things. Demonstrating that to primary school kids, I think, is super tricky. But I think once they get a little bit older, potentially all grades of high school kids could have a go at running like simple economic models where all of these are put in as variables, and then there's a little bit of a maths lesson in there around distributions and probabilities and different distribution styles. And if you have the fundamental model in, you can have it as something as basic as Excel with a little plug-in. I often use a plugin called Aurisch, and you can actually have the kids run Monte Carlo simulations, and they can play with the inputs. They could see what the result is, and see how much varying distributions of any one of those parameters affects the feasibility of a resource. Tricky for primary school kids. It's the feasibility of a mining operation might not be there.
And one of the things I did put together with Ross Wilson 4 or 5 years ago was an exercise in exactly that. It built a little hypothetical copper mine. We gave them some geology cross sections and drill holes, copper grades, that sort of thing, to get the students to start to look at projecting those grades and working out volumes to hold those grades, how many tonnes you're going to get out. And understanding that it's not just a matter of saying, well, I have a blob down there, it's really high in copper. You've got to get it out. And to do that, you've got to mine a whole heap of stone and waste off the top, which costs a lot of money and potentially makes it to the mess of the surface. Has anyone here heard of JORC? It's Joint Ore Reserve Committee, and it's something I've been involved with for 40 years since it first started. And it's become an international set of guidelines for resource and reserve estimation, among other things, but they're just about to introduce a revision of that, which will come out hopefully this year. And that introduces much more stringent reliance on ESG components. So not only looking at the factors that Karen mentioned, but also particularly the fourth one. We've got all of this stuff. Looks like we can dig it out and make a monster, but should we be doing it? And if we go ahead and do it, what are we going to do in terms of maintaining safety around release of any nasties into the environment while it's in operation, and then cleaning it up afterwards? That JORC standard, which has been developed here in Australia, has become essentially the worldwide de facto champion. Simple. And most of the other similar guidelines, like standard others in the US, are based on the Australian JORC system because of its genuine responsibility in getting people to make sure they know what they're doing. Hopefully responsibly as well as like.
Well, I think that just really was. And this may be of interest to the older students. There's a number of companies now that are starting to put example I spoke about out as competitions. So some companies do it more than others, and it's a little bit cheeky potentially because they're basically finding exploration. But the way that's contexted is that they are, many different minds will come up with great independent ideas. Back in, 3 or 4 years ago, I entered the Master Minerals one. And the prize money in total was $1 billion, right? So we're not mucking around. And we tried to bring, sort of petroleum exploration methods, which are obviously looking deeper in the subsurface, to the mining space, and we ended up highly commended. Still furious about it. It's a little bit tricky because you have to know where to look. And I'm not saying people should be motivated entirely by prize money, but there are opportunities to participate in, these kind of fun but real exercises, right? Where companies provide all of the data and the sort of instructions and have it go. At the end of the day, there's real benefits.
Thanks, Sharon. That sounds quite exciting.
That's amazing.
Do we have any more questions from the floor at this stage?
We've had some really good discussions in the chat.
That's good. Okay, I've got another curly one then for Joanne. Students need to analyse stratigraphic sequences to determine relative ages. What common mistakes do you see people make in interpreting fossil evidence that have to help students avoid these?
Yeah. So I did have a think about this question. There's two comments I'm going to make. So we all understand that, layers that are laid down first are older. And then as sedimentary layers go, they go young and younger as they go. So mostly, exactly. So there's always just the whole idea of not getting too stuck on what you think is happening. There's always exceptions to the rule. And I'm going to tell you a story about my biggest embarrassment moment that caught me out so big time, and I never will ever go there again. But I was working on a dinosaur. So there's dinosaurs up around Winton. Many people may have visited. In the early days, there was a dinosaur called Elliot, in the very early days. And I was working on a block of bone that was near the first bone that Elliot was found. But we didn't know whether it belonged to it. It's very exciting. And they set me up on the second floor of the museum in a kind of a fishbowl. So everybody could come into the museum and see us work on this. And it was in a great big plaster jacket. So there's the bone, big bone. And I'm working with my little tool, making lots of dust, and everybody's coming in having lots of great. Anyway, this one day I found a very small bone, and you're not supposed to find very tiny bones in a dinosaur. Like these bones are huge. So I found this tiny weeny bone, and I nearly died of excitement because I knew there wasn't supposed to be anything small in this jacket. So I thought I either had a baby dinosaur, or I had a small, incredibly interesting thing that was 100, because this thing was it's about 97 million years old. And I embarrassingly was so excited. I ran up the stairs to the CEO's office, and I walked in and I announced that we had a small dinosaur that was coming out of beside this big dinosaur. So he was very excited, and the media person was about to do a great big media story. Anyway, I went back down, and this incredibly very experienced guy who works the museum walked past, and he said, "Joe, it's a wombat." And I went, "Can't be a wombat. It's 100 million years old. These sediments are 100 million years old." And he went, "Joe, it's just dug down from the surface and just decided to die in amongst these dinosaurs." And I was so mortified. So it taught me that never, ever again will I just go along with the flow and think that because the layer is down there, it's older than it. It was such a great lesson in life, really. And I had to go in and tell him that it was just a wombat. But it was a wombat that wasn't there anymore. So it was an extinct type of wombat, and it was kind of important in its own way. I'm getting back to the question. So first of all, don't ever expect that the lower ones, because there's lots of things that happen under the ground. And can we help not? I wonder if Keegan's got any ideas. How can we stop students getting a bit confused with that one?
Stratigraphic sequences can be confusing, and I agree there. It's not really something that juniors tend to grasp, but in the senior syllabus, when I was designing activities for it, what I did was created A4 printouts of different sections and they each had their legends. And we talked through all the different types of rocks that would be included in this sequence, all the different types of fossils and whether they were in there in combination with others. So I guess index fossils, that sort of thing. So we're covering a few concepts here. And then they had to go around as a class and find their person and blue tack it till we had this massive stratigraphic column, and we put it on the board, and then we can start to draw a time scale across from that column that they've constructed based on the index fossils and the rock types. So for example, if there was a dike in one section, we knew that that one had to be younger. And so we could look at lots of the different laws as well as how a stratigraphic column is created. And I found that generally because they're engaged in it and you're not just teaching it, they can understand that concept of the stacking of layers, the cross-cutting, all of those different laws a bit better. What did you think about that, Joanne?
Yeah, no, that's great. But one other thing that I've done with younger students, this is again, I think they were younger students. The G-Bum site that was found about 15 years ago in Brisbane is an Eocene site. So it's around 50 million years old, was found down below the ground while some rail work was being done at the G-Bum train station. So down there, the guys who were working at the site saw fossils coming up. They contacted the museum, and that site ended up 6 tons of that site under the ground was excavated and dumped at the museum. We still have it, but highly significant. That is the age when dinosaurs became extinct, and then it's the rise of the mammals. So really incredible time. We don't have that much of it exposed in Australia. There's Mergen, which is that age group, and a little bit out at Ipswich, actually at Red Bank Lanes. But that was just very, very exciting. So the local school, we were able to go out and do some really intense stuff with them because it was so close to their school, and they gave us the money to go and do it. So we ended up getting buckets, but you can't fill the bucket up and then turn it upside down because the stratigraphic unit gets all upside down. So you have to fill the bucket and then have the outside of the bucket split and then taped up again. And every time you fill the bucket, it's got to be from the top. Each child has a different coloured sand, and then the bucket's got little holes in it so that then some other child in the group waters the bucket and then pushes it down. It's all nice and compacted and a bit wet. Then the water's all coming out. And then after, 10 or 15 minutes, that sand is really, pretty hard. And then you can peel off the outside of the bucket and then cut the whole section with a knife. And that's pretty cool. And it stays in place. And you can actually salt it with a few fossils as well. So that worked really well with the little guys. The little kids, they loved that. Yeah.
Makes me want to come along on some of your field trips.
I'm going to add a plug for size.
Oh, yeah.
It's a joke. It's not a funny joke. Seismic interpretation is colouring. So I feel like, if you can apply it at any level, potentially, if you can get your hands on seismic sections, and seismic sections are basically an image of the subsurface that we acquire and process. And stratigraphy there, it's you're matching patterns, right? So this looks the same as this, so that means all there. And then, where it's not that straightforward, this looks different from that. Why is that? You can see big faults on the surface. Yeah. Like one of the most fun ones is to look at salt, because salt flows. So it can be deposited right down the bottom, and then, things can happen structurally, and if you push right up and, balloon just below the surface. So all kinds of interesting things. But seismic sections, I think, are a great way of showing it because, really it's about colouring things that look the same. Yep. Yes.
All geologists or
Yeah, colouring in. And matching the shapes. You print the seismic lines off, and you get your colour penciled out literally. And go like this on the table. Did you ever do that? It was pretty much. No, but I have done it for exercise, yes. So I think if you're struggling to get a hold of seismic exercises, again, sing out like, it's a good one. Yeah.
Thanks, Sam. Another question for you, Keegan. Number 4 there, I don't know if you've got your sheet. How can teachers incorporate local water and geological issues into their curriculum to help students understand the relevance of earth sciences to their everyday lives and communities? And that's a very broad question. Having these days, the effective, or rather the matching up of waterways from geological and industrial activities, that sort of thing. How do you then raise those questions with students, get them to be responsible, but also learn that we still have to do things, we still have to learn, we still have to farm, we still have to mine, but in a responsible.
And I think it's a lot easier for students, this particular topic, when they're in a regional, rural or remote location. A lot of them are very aware of water scarcity and the different types of water uses. The Murray-Darling Basin, we do have a small section of it, and that is a really great case study to work through with students if you're in the Darling Downs, because you can examine salinity at a broad scale and also upstream, downstream contaminants. Now, I've worked up in the Cape as well, and looking at contamination from different types of mining. You do have to introduce some chemistry to the students in a senior level if you're wanting to look at specific impacts of mining. But at a junior level, understanding the different amounts of water, and this sort of leads into geography. It's sort of very cross-disciplinary, this topic of water, because in Year 7, geography students examine water and what it's used for, where it's distributed. And then further in Year 9, they examine biomes. So they're looking at the impact of agriculture and, again, industrial activity on biomes, often looking at water when we look at an Australian case study. So if we can trace back sort of a water supply and help students understand where their water comes from, regardless of year level, does it come from a dam? Are we pulling it up from underground? And looking at a map of locations of the different types of industry near those water sources. I put a couple of links in there, and Queensland Globe is a very easy access database for students to look at. You can look at different mining layers as well as different water catchment areas and groundwater resource areas. It leads to that critical thinking level of relationship comparison between different layers to understand if there is a water level here upstream that is going to be impacted by potential runoff from a mine, or if there's going to be nitrogen fertilizers that are running into the water, where is that flowing to? And again, it's that geographical thinking that doesn't often come into science specifically. So I would always caution that with chatting to a humanities teacher, making sure that you are not doubling up necessarily. But students generally in Australia understand water quite well, because if you're in a regional, rural or remote location, they know the different salinities of their bores. They know where they can or can't drill it. If it goes into a coal measure, you're going to get sulfides in your water, and that's not going to be very nice when you're pulling it up. So it's gauging what they understand and focusing on that supply chain, linking it back to geographical locations of industry is my way of linking it, because it's very place-based and real life. But I come from a geography background too. I'd be interested to hear what other people have to say on that.
Thanks, Keegan. You raised quite a few good points there. I think things that I hadn't thought of in terms of knowledge of people, particularly living in rural areas. They're obviously very switched on water scarcity issues. For Karen, career pathways in the resources sector aren't always very clear to students, and this has been a problem forever. What advice would you give to a Year 12 student interested in geoscience careers, and what skill should they be developing now when they commit to that?
Okay, so advice-wise, I think there's a few places you could look to tap. I think keep an eye on company websites for vocation work opportunities. I think if you can find the industry body that exists that's aligned to your area of interest, jump online. They'll have events every month. We do an ASCG, he does. And generally very welcome if students no cost. So go along. to those events, and I don't know if students be networking, but you make introductions, get to know. Then, of course, there's the standard sort of university career expo. I think I don't know if schools do their own expos, and that's all the physical in-person stuff. But then again, going back to online, TSEP, AusEFed, and hopefully one day soon, ASCG will have some helpful resources on their web pages. So I think in general, what I'd say is if there's a student who's genuinely interested, enthusiastic, anyone in sort of our networks will go out of our way with advice, whatever you do to support them getting started. In terms of skills, I think data science is a big one because, when you start in the space that I started, the first thing you do is you talk to the company about and strategy online with sovereign risk, all those kind of things before you plow into an area. However, that's sort of the boring stuff. The exciting stuff is then collating a database, right? Just everything. And getting that right, which involves a whole lot of data cleansing and calibration and so on, is the key to then having interpretations that mean something and get you a discovery or a result. So I think data science is quite a handy skill to have, and I'm already outskilled. I'm working with Canopy and Excel, like copying and pasting. Like, I might be just flying data around the place. It's impressive. Well, ADLA again is quality in, quality out potentially, like rubbish in, rubbish out. So that's a whole. But I'll end the question with a little anecdote, which is related to the time I was a VP and they asked me to get involved in the graduate recruit, which was super interesting, and I didn't show any interest in it. So I don't know where the request came from. But, what I learned through that was that, and I think subsequently, now that I know it, I could see it, a lot of companies look for kids that demonstrate, they can apply themselves to a subject. So good results are part of it. But having the exact skill set that is required for the job is not a prerequisite, because what BP said was we can teach anything. We can coach anything. We can learn on the job. What we cannot bring to the equation is, and this is the word they use, drive. So what they said is, number one, you've got to look for kids who actually care, who have some passion, who genuinely want to be in this space and have an interest. So that's what they're looking for, number one. And I don't know if you can manufacture that. I think you just have to have it. Then underneath that is demonstrating apply themselves. So that's, I think roughly aligned half decent grades. And then I think below that is literally, have you done this subject? Do you have that skill set? Because to be honest, for the on the job learning, they think should cover that. That's no problem.
Yes. Thank you. Just following up on something Karen alluded to, in your classes, if you're aware of anyone in your class that is a geologist or knows a geologist, come and talk to them. Get them to come and talk to the kids in your classes. You'll find 99% of geologists are more than happy to do that. We get requests through the GSA to do that, but we've had a lot of schools tell us that they know geologists, parents, or kids in their class, and they're always very happy to come across and tell the kids, bring along some nice shiny rocks probably as well, but just explain what a geologist does and the fact that they don't have two heads or things like that. Well, most of the time. But you'll find them very accommodating, very encouraging. I'm always very happy to go and do that. We've kind of, as have most of the committee over the years. So yeah, don't be afraid to go and run in, get the whip out.
We have one last question.
We have one last question from Tara in chat asking Keegan about why they decided to become a teacher.
Thanks, Lara. So I guess when I was 4, I walked into preschool and told my teacher I was going to be a geologist. But none of my teachers really knew how to support me in gaining that goal. When I was in high school, Earth and Environmental Science, I think most people have said they shove it at the end of a term. They try and just get through it. It was never really a focus. In senior, I didn't have the opportunity for Earth and Environmental Science. And I went on the National Youth Science Forum, which is a great program that they take students out to explore and engage with other high achieving science students. And I got to be in the Earth and Environmental Science focus group, got to go to Geoscientist Australia State, ANU, that sort of thing. And it really reinvigorated my sense for geoscience education. I then did my degree, went into the field, loved the field work, but realized that there was just that lack of information around what a geologist actually does. People didn't understand why I was testing soil and testing water and how that linked to geology. There was a lot of stakeholder disinformation and misinformation when working with them. And generally, as a society, I just see a lack of understanding for earth science. So I threw myself back to uni and almost through it. And I think that being at my university, there were 6 of us nationally who were in the subject for senior earth and environmental science. My university is national. So we were all online and there were 6 of us doing that senior subject. So it's very, very clear that we are in desperate need of earth environmental science teachers. And there is a gap to fill for this generation in terms of understanding our impact on the future around geoscience. So I'm hoping that I can just fill a small gap wherever I am and have a small impact so that we have more geologists and people who appreciate our earth.
And thank you very much for having the courage and the drive to make that decision and take that leap back to contributing back to students. It's a really, to my mind, undervalued role in many ways. I think a lot of the public just take it all for granted. Teachers are there just to do their job, but they're not. They're very passionate. And we've met some amazing people in industry across the years. Take your heart to. Well done. Thank you. Have we got time for one more question for Joanne?
Oh, yes, just one more.
Students struggle why some organisms fossilise better than others.
Yes.
Can you share some examples from your work that might illustrate this concept? For example, collection is mainly composed of hard parts rather than soft tissue preservation.
Yes, it is. So, yeah, that's a generalization, I suppose, because we have a huge lot of fossil plants as well, and some of those are quite soft. So it's true that most fossils are hard parts. So, the bones of an animal are, and certainly teeth, are really resistant to breaking down in the right conditions. So we do have a lot of that. The soft parts are being picked up more and more by new technology. And so we're finding, well, just an example for me, when I first started 30 years ago, we would find diprotodons out around Toowoomba, and we found a beautiful lot of skulls. And I was working on preserving those skulls as a trainer. And around the teeth of other molars of the skull, there was this kind of funny stuff that we thought was it looked like it was like carbonate, just carbonate that had filled in the area. Now we know that it's dentine, so it's like quark, or and it's part of the animal. But I used to be churning it off like, oh yeah, it's a little bit of it. Anyway, we realised that wasn't, so that's not done now. That is just the soil's taken away, this dentine's left there. And that's happened over the years that I've been there. Much more of the soft tissue is being left and recognised and left. So that's pretty cool. And that's been picked up by micro CT scanning and all sorts of really groovy stuff. Even some of our materials taken down to the synchrotron now and shown through the synchrotron. And that shows internal structures of seed pods and all sorts of incredible things. So the beam time down there is free. You just have to apply to it. The government runs that facility down there, and there's amazing images coming out. And just while I've got the microphone, can I just give a plug to the Queensland Museum website? If teachers go on that website, there's resources available there. There's fantastic. I've brought along some loan kits tonight that are aligned with the curriculum that are available for borrowing and that can stay in the classroom for terms. And there's also resources online that you can download and work with your class for a whole term. There's 24 sites around Queensland that you can pick up and drop off these things, but you do have to subscribe. So there's a cost in loaning them, but a lot of the material online is free. So there's lesson plans, there's all sorts of amazing stuff. So these images, there's also 10,000 images of objects that are on the collection. So we're adding to that every year. So it's a digital, they're digital images of our collections. So if you need a image of something, go on the website and just see if you can find something, and then just have a look if there's a kit available for your teaching needs. So that's a source. Did I answer the question?
You did.
Right, good eye.
Thank you. I think we're just about out of time, but I've got one more question here for Karen, just before we finish, and I think it's an important one. The syllabus requires that students understand environmental monitoring around mining operations, which has always been quite a big thing. What are the key environmental indicators companies like Arrow monitor, and why are these important?
Okay, well, so high level first. So monitor all kinds of things. So air and water quality, noise, vibration, impact on surrounding ecosystems, waste management, rehabilitation, awful lot of monitoring going on, which is obviously important. As far as Arrow is concerned, Arrow is a coal seam gas company. So its primary concern is monitoring water. So that's groundwater and extracted water. So that's for changes in water quality, levels, once water is processed, contamination, things like that. And they do that via sampling and water monitoring boards, which are put out, and monitoring. I think the regulations say at least 12 months before any coal seam gas extraction starts, so that they've got a base, basically. So Arrow is very focused on water mining operations more so.
You just mentioned one that a lot of people perhaps aren't aware of, and that's vibration risk. Things like longwall mining in coal areas can create some significant vibration risks, which may upset, for instance, foundations and buildings.
We operate on often not Crown land, right? It's privately owned land. So our license to operate is dependent on, getting access from landholders. So correct, doing the right thing. And I know there's lots of instances of horrific things that have passed. The intent is there. The monitoring is in place to, avoid that.
Thank you. We're just about run out of time, but I'd like to take this opportunity to thank governors. It's always a difficult environment when you start putting together environmental science and earth science and those greedy geologists out there who just want to rape the village. Most often very studious and very aware. It's always, the really good set, a question of balance. Between earth and environmental science and between what we need to do everything that we want with our lives and the cost of digging those materials out to meet those requirements from a very diverse set of human beings on the planet that we see more and more check out. Keegan, thank you very much for your time. Great to catch up again, and I hope we catch up again too.
I'm sure we'll catch up in person at some point. I just appreciate being able to join in online. Thank you for having me.
Great. And thanks, Joanne.
Yes.
Let's hang around, have a look at the fossils that Joanne has brought in. The rocks and landscape. I've brought examples in, so have a look at those, and they can all be ordered online with us cheap tips and give you a great resource for discovering geology around the place. Thank you, Karen.
And thank you, Tony. And to all our speakers tonight. We do have some little speaker prizes or thank you appreciation for each of us. So there are 4 different ones. Don't worry, Keegan. As we said, we will get yours to you. For those of you in person here, we now have a networking session with some peoples and drinks. And for you, to everyone online, thank you so much for joining. Thanks for braving through the technical difficulties, and hopefully you've still got something else that we'll be bringing through those resources to you soon. and hand over to Fernanda for the final little survey.
Yes.
Just to make sure that we get that feedback from you all. I can wax the recordings a little bit longer. I've got some fantastic rocks here. So we have some fluorite. We have a beautiful basalt bomb. So they're from all over the world, from Tara Minerals, and thanks again from WOMEESA, Inspiring Australia Queensland, and UQ, who are involved in hosting that here in Queensland, and GSA, who suggested Tony as our fabulous moderator. And I think I can really stop talking. Fabulous, some great photos that we can have a look at and send to you later.
Yeah, thank you so much to everyone. If you could scan that QR code, that will help us to improve this type of events. But I'm also sending the link to everyone who registered for this event. So if you cannot do it now, that's okay. And we are also putting together a resource for everyone who registered with the topics that we discussed today, and as well as all the resources that were shared. Thanks, everyone. Thanks for joining us online. For those in Brisbane, we have a networking session now. Thanks.